Welcome to Bite-Sized Data Science. In this installment, we are looking at another machine learning classification algorithm, Naïve Bayes. It is called naive because it assumes no overlap in the classification. This works fine if you're writing a spam filter. A message is either spam or not, but when it comes to document classification, for example, a document can be part of multiple categories, so Naïve Bayes can still be used, but it will have issues. The Bayes algorithm refers to the probability of one event is impacted by the probability of another one. So the Naïve Bayes algorithm can be used in areas such as spam detection, document classification, customer classification, even for sentiment classification. Let's take document classification as an example. A classification algorithm looks at the similarities of a document and, based on the similarities, offers an answer. We can look at it as how far apart are two documents, somewhat similar to the k-means clustering we saw in a previous video. Two major differences. We are given the answer so we can find out where to put a document during training, and we are dealing with words instead of numbers. How do we go from a bunch of words to numbers? This is easier explained using an example. Let's say we want to classify documents. We first need to prepare the documents for modeling. One step is to convert all the words to the same case. This way the same word won't be seen as multiple words. Another step is to remove what are called stop words. These are the words that don't add to the meaning of the text because they are likely to be found in all the documents anyway. Words like the, at, my, of, on, when, while, and so on. This will make a significant difference in the overall size of the document set since these words are usually found multiple times in each document. We can continue to reduce our document set size by using stemming. This is using the root of a word instead of its many derivations, including singular and plural. For example, the word stemming would be reduced to stem. All the words with the same stem then match to one word. The final step is to convert each word to a number using a hashing algorithm. You will want at least as many possible values as the number of different words in your document set. If the number of values is too low, you will have multiple words falling in the same bucket and therefore be seen as the same word, which reduces the accuracy of the document comparison. Once we have the documents converted as a list of numbers, we create what's called a sparse vector that represents an ordered list of the hash values found in the document and the frequency of that hash value. This means that the number of entries in a sparse vector is the number of different hash values in the document. Now we're ready to feed the document as sparse vectors to a Naïve Bayes algorithm to create a model. Once we have the model, we can pre-process a document and feed it to the model as sparse vector to find out where it belongs. There's a bit more to document classification, but you get the gist of it. You have to convert documents to numbers and let the model figure out how close a document is to each class that was defined in the model. Remember, if you want to do things like spam detection, document classification, even sentiment analysis, the Naïve Bayes machine learning is a candidate to implement a solution. See you next time on Bite-Sized Data Science.